Hello everyone, Assalamualaikum, a very good day. So this is lecture for EMM 3518 Computer Aided Engineering Drawing, and this is for lecture 10 and it is about the working drawings. Before I start, just a reminder that this is just a very quick brief about lecture 10. I really hope that after you watch this video, you will put some effort in reading the notes given in lecture 10 and do some exercises. So I'm going to start with some pictorial drawing. The drawing that we have here is to help us to visualize all the information needed. And the purpose of having drawing is to enhance the ability to visualize the thing, to identify the design features, as well as to show parts that can fit together. And we already learned in our previous lectures about different pictorial methods such as the axonometric, oblique and perspective drawing. And today I'm going to focus more on the working drawing, where working drawing is a set of drawing used during the work of making a product, and it can be divided into two types. The first one is the detailed drawing and the second one is the assembly drawing. In terms of definition, detailed drawing is focusing only one single part that is equipped with the dimensions and note, while for assembly drawing is the drawing of various parts of a machine or structure that have already been assembled together. That's the clear definition between detailed drawing and assembly drawing, where the detailed drawing is more focusing on convey the information and instruction for manufacturing the part, because it's just focusing one part. However, for assembly drawing, because it's contain a lot of part, it's convey completed shape of the product, overall dimension, relative position of each part, and functional relationship among various components. And all this information can be provided in a title block. We're going to start with the detailed drawing first before we go to the assembly drawing, because detailed drawing is just focusing on part. Normally, the information given in the title block provided all the general information as well as the part information, including the shape, size, and specifications, and other information as listed here, including unit, scale, method of projection. And the part information, normally the shape of the parts can be either in the shape of orthographic drawing 2D or in the pictorial drawing 3D. And also the size need to be included in terms of dimension and tolerances as well as other specification. And these are some recommended practices. Draw one part to one sheet of paper. If not enough, make sure that enough spacing between part and the parts drawn using the same scale. And some other standard parts such as ball, nut, pin, bearing do not require detailed drawing because it's already in standard. And this is kind of like the arrangement for detailed drawing, where we have the completed dimension orthographic drawing, we have the title block and also notes here. And this is the example of a detailed drawing. You can see here we only have one part from the side view and from the front view, and this detailed part consists of the dimension in order to provide us more information. And beside it, we also have the title block as well as other information in a title block. Okay, now we move to the assembly drawing. In terms of assembly drawing, it can be divided into three. It can be either exploded or general or detailed assembly drawing, where exploded is the parts are separately displayed. All parts are separately displayed, but they are aligned according to the assembly position and sequence. And this is the example of the exploded assembly. All the parts are included here. However, it's not assembled yet, but it's in line to the position where it should be assembled. And this is for the 3D, and this is for the 2D orthographic representation of the exploded assembly drawing. You can see that the different parts had been put aligned together at the position where they should be assembled. And beside the exploded assembly drawing, we also have the general assembly drawing, where the general assembly drawing is that all the part already been fit together to provide the image of the complete unit or complete machine, such as like this one. This is the 2D orthographic picture, and this is the 3D pictorial drawing. And the only information given here is some balloons here showing different part of the unit, and some dimension can be provided in the general assembly drawing. However, only some dimension that are related to mission operation. And this is the example of a general assembly drawing, where we already assemble all the parts together to provide a complete drawing like this. And the only provided thing here is the balloon to show different parts here. And beside that exploded drawing as well as the general assembly drawing, we have also the detailed assembly drawing, where the detailed assembly drawing is kind of like similar with the general assembly drawing, but it has all the information in terms of the dimension and so on. So this is more informative for us, but it's a bit more crowded as to compare with the general assembly drawing. And some information required in the general assembly drawing as listed here. What I want to highlight is that the bill of material we call as BOM, where we need to put this, it should include the item number, the descriptive name, material, and the quantity required. And this is something that need to be provided for the general assembly drawing. Okay, in terms of the placing of the drawing, is going to be like this, where the boom should be on the top of the title block. And this is one of the example of the boom, where number, we can start from the bottom here, number 1, 2, and 3, and part name here, and the required part like this, and also the material. And this is another example of the general assembly drawing, including the BOM, the bill of material. So these are the steps to create assembly drawing. You can just follow the step one by one, starting from analyzing the dimension of all parts, and then until the end, after you combine all the parts together, you need to create BOM, and also balloons, node and dimension if any. And some practices that you can follow, the number of view can be either 1, 2, 3 or more, but normally it should be minimum, so normally we only have 1 or 2. And a good viewing direction is that it can represent all of the parts assembled in their working position. That means if we combine all the parts together to make the assembly drawing, the viewing direction should consist of view that can represent all the parts. I can show you in the practice here. So if you were given part A and part B, which one do you think is the good assembly drawing, whether A or B? So here we have B is the better view for the assembly drawing, because it kind of like show different part, the part A and part B of the assembly drawing, compared to A, we only show the part A. Another general practice that you need to highlight is that sometimes hidden line usually we can omit unless they are absolutely necessary in order to provide more information. Okay, so there are few practices that you can do here that you can try and see if here which one is the best one. If you have part A and part B, whether we need to omit or not the hidden line. you can try to see which. I think A is the right answer. Yes, A is the right answer, because although hidden line sometimes we need to omit, but this one we still need to make sure that the detail of the hidden line should be provided in order for us to give information about part A and part B. And there are other exercises that you can do, and this is after you complete this video, you can do the exercise on your own. Another general practice is the section technique is usually need to clarify the mating of the part, where if you can see here, if we have two parts and we want to make a section, the way to do it is to do different section line. This is with color. If you turn off the color, it's going to do like this. So the direction of the line should be different, so that we know that these are different parts. And do not draw section line on sectional view of standard is another practice that you can do, where you can try to understand how to do it by doing this exercise. It's really interactive. You can do it by your own, and after you do it, you can get more understanding about the practices that have been highlighted here. Okay, beside that, we also have the leader line, the balloon drawn in the oblique direction. Example, if you have the shaft, the cover plate, the bearing, the cap screw, so it should be fixed like this. So these are some of the exercises that you can do in order to get some more understanding, interpreting of the assembly drawing. When we have assembly drawing, what we can do, there are few steps. The first step is to assemble step, and then we can function of each part in machine should be identified, and the design concept. And there are few examples here where we have the assembly drawing already. The first step is to try to assemble step by installing, okay, this is the shaft support on the machine housing, install bearing to the shaft, and then install the bearing shaft unit to the housing, install the cover plate, and tighten the screw. Okay, this is the assembly step. And then the function of the main part, one is the bearing, the cover, and the design concept is try to avoid direct contact between rotating shaft and housing, as well as cover plate, by using a bearing and clearance hole. So these are few steps that is required in interpreting the assembly drawing, and we have few examples here. This is example number 1. You can just have a look. And example number 2 is about the leakage of prevention unit. You can go through. And example 3 is fixing parts on the shaft. Another example is part with tapered hole on tapered shaft. This is the assembly step, function, and design concept. And this is another example, part having pre-loaded spring. So this is interpretation of the assembly drawing that I hope going to give you more information about how to do the assembly drawing. I believe this lecture should give you some information about how to do the assembly drawing and how to differentiate between assembly drawing and the detail drawing and so on. And hopefully after this you're going to do the exercises in the slide here to get more understanding about those concepts. Okay, I believe that's the end of the lecture for this topic. Thank you so much for watching. Bye bye.